it might be two solutions, or it might be one solution. Okay, so you know that SSA is not a congruence pattern, right? So that's why there might be two or there might just be one. But let's talk about how you can distinguish those. Okay, so let's say we take these two examples. They both have an angle of 21. They both have a side of 10, and they both have a side of 15. Okay, so each of these has the pattern SSA, right? Two sides and the non-included angle. Okay, but when you look at these, you're able to determine which of these has two possible solutions and which one has one by looking kind of visually at some of their properties. Okay? When you look at this top one, and the fact that this, of the two given sides, the fact that the smaller of the two is opposite the given angle means that if we were to imagine hinging this side of 10 at the point where the side of 10 and 15 intersect, and if we rotate that over, what you'll find is there's a second possible triangle, this red triangle, that has the same angle of 21, side of 15, and side of 10. Okay, so here there's two possible solutions. Okay, and so the indicator for that is if of the two given sides, if the smaller of the two sides is opposite the given angle, then you have two possible solutions. And now, visually, I drew this out and kind of exaggerated the difference in lengths here, but visually you should be able to kind of see the relationship here. If this side is 15, is there any way that we can hinge and rotate it back so that it fits and forms this other triangle inside? No, and the reason for that, if you look closely at these two, so here's the one that exists and the one in dashed lines that doesn't exist. Okay, when we form this triangle inside the other triangle, we're going to have an obtuse angle right here. Okay, so if you check the properties of a triangle, is it possible for this triangle to exist? Can you have an obtuse angle here and a side of 15 here when this side is 10? Yeah, because you expect opposite an obtuse angle in a triangle is always going to be the longest side, right? So 15 versus 10, that is the longest of the two sides. So this one is consistent with what you know about the properties of a triangle. But when we look at this one, what would happen? If you had an obtuse angle here opposite a side of 10, but you had this other side of 15, is that even possible in a triangle? No, because you can't have two obtuse angles in a triangle. So this one is inconsistent, it doesn't work, so it's only going to be one solution. Okay, so the indicator of one solution is of the two given sides, the longer of the two is opposite the given angle, and up here, the shorter of the two is opposite the given angle.